This is the German deep-sea fishing fleet's most cherished super partner. Right now, it's sitting in the port, eagerly awaiting its next voyage. Just one trip out to sea can net a whopping 6,000 tons of deep-sea herring. The logistics crew are working at full tilt to restock supplies. Not a single minute can be wasted because, as everyone knows, time is money. A typical fishing expedition lasts for weeks. During the journey, they'll encounter the ever-changing and extreme marine conditions. But for these sailors, this is a job straight out of their dreams. Whenever they lay eyes on those glistening piles of fish, they affectionately call them deep-sea silver. These fish catches are obtained by towing a trawl net that is hundreds of meters long for several hours. Beneath the ship's deck lies a huge fish processing factory, equipped with a complete cold chain processing system. This allows the workers to operate around the clock, 7 days a week, whenever the fishermen set sail. They actually have no idea exactly how long they'll be at sea on that particular trip. If they encounter severe and extreme weather, it could take even longer. However, come what may, as the captain, Gabor is responsible for the safety of all 58 crew members on board, as well as the cargo and the vessel, ensuring that they all return to the port safely. This is Captain Gabor's top priority. He says that once he's out at sea, he's not interested in anything else.
This is the Teodoro, a deep-sea fishing vessel specifically designed for trawl fishing operations in the Pacific fishing grounds. It spends over 300 days a year navigating the deep seas, measuring 140 meters in length and 20 meters in width. Today it is berthed in the dry dock at the Port of Amsterdam. Workers are applying a fresh coat of paint and conducting maintenance checks on the ship's facilities and equipment. This is because every fishing trip at sea may cause varying degrees of equipment damage, necessitating technical inspections upon docking. For instance, they need to check the operation of the rudder, whether the steel walls of the propeller are worn, and the sensitivity of the electrical and electronic devices. If any malfunctions occur, they must be repaired within 24 hours of entering the port. Currently, the captain is overseeing the maintenance process, inspection of the anchor chain. Like this, is one of the mandatory items. The chain itself wears out over time, with its thickness reducing by approximately 5 millimeters every 20 years. Meanwhile, special attention must be paid to the sonar device. Fishing in the dark seabed relies entirely on this device, which is like the ship's underwater eyes. Usually, when fishing, the low-frequency sonar is used first. The low-frequency sonar can locate shoals at a greater distance, up to 3 or 4 kilometers. Once the ship approaches the shoal, the low-frequency sonar loses some of its positioning functions, and then the high-frequency sonar system is switched on.
There are 4 sonar systems on the entire ship. Losing even one of them would significantly impact their fishing results. Finally, the cargo hatch covers, weighing several tons, need to be hoisted onto the deck. Since the crane on the starboard side of the ship is damaged, they have to rely on an externally rented crane for the lifting operation at this moment. The second mate is communicating with the crane operator via a radio. The cargo hatch covers are slowly lifted and positioned above the hatch on the deck. Several workers are manually assisting to adjust and align the position. Meanwhile, the workers in the dry dock start the water inlet valves. In a few hours, the Teodora, this deep-sea fishing vessel, will float again. Germany's largest deep-sea trawler is about to be towed through this river port, embarking on a new round of deep-sea fishing expeditions. The crew members are getting ready on the bridge. First, the first tugboat takes its position, and then the second tugboat arrives at the stern. The deck crew throw the mooring ropes onto the tugboats and secure them. The connection between the trawler and the tugboats relies entirely on this huge winch at the stern. Next, the 2 tugboats, one in front and the other at the rear, will tow the massive fishing vessel out of the narrow port. All the captain can do at this moment is simply control the direction in the engine room beneath the deck. Only one engine is running at a low speed. Early the next morning, Germany's largest trawler had already docked at the port of Netherlands. It's time to gear up for the impending fishing expedition. First on the agenda is checking the crew list. From this list, it's clear which station each crew member is assigned to and what tasks they'll carry out. More than 4,000 pallets have been brought to the square. These pallets are mainly for storing the packaged and frozen fish catches. Amazingly, they can load a truck full of pallets in just 5 minutes, and the whole process will wrap up in only 1.5 hours. Meanwhile, the deckhands are busy counting the pallets. Their aim is to make sure that every inch of space in the central cargo hold is put to perfect use. Meanwhile, various daily necessities for the crew are also essential. They need to stock up on food and drinking water sufficient for 4 to 5 weeks. Additionally, there are items like chocolate, Snickers bars, etc., which are for sale on the ship. However, the most crucial item is cigarettes. Without cigarettes, the crew's mood will deteriorate rapidly within 3 days. These cigarettes are immediately taken to the storage room and locked up after delivery because they are duty-free and not authorized for sale on land. At the same time, the navigators on the bridge must conduct a series of operational checks on the ship's systems. Usually, they need to check this black box. Every fishing vessel is equipped with such a device, and it is necessary to ensure its normal operation. Its function is to enable the fishery authorities to see the location of the fishing vessel at any time, so that rescue can be carried out immediately in case of danger. Once all supplies and cargo are loaded onto the ship, the captain conducts a final inspection. This is to ensure that no large, heavy items are left unsecured, as that could pose a safety risk. Everything must be fastened in a way that makes the ship seaworthy. Subsequently, Captain Gabor boards the vessel, ready to set sail. At this moment, a tugboat approaches and hauls the trawler to open waters, specifically 5 nautical miles off the coast. Their first destination is the Dover-Calais fishing ground, which is located 400 kilometers away. This is one of the world's narrowest navigational areas. Teeming with fishing boats, everyone hopes to catch plump herring there. This is the kitchen on the fishing boat. The cook has to get up at 4 a.m. every morning to start preparations. Then he needs to bake enough bread. Meanwhile, the second mate has to assemble the crew on the deck for a morning meeting. Everyone on board is required to attend without exception. Subsequently, the roll call begins. The second mate needs to inform everyone about how to handle emergencies and the work arrangements for the following days. Soon, the bread in the kitchen will be almost ready. After having breakfast, the busy fishing work will kick off. The Theodora, Germany's largest deep-sea trawler, is on its way to the Dover-Calais fishing ground in the English Channel. At present, it is sailing westward towards the Atlantic Ocean, aiming to catch more than 6,000 tons of herring. The fishermen are on the deck, getting ready a fishing net over 700 meters long. They measure the distance with a tape measure and fix the sensors. The sensors are used to send crucial information about the fish shoals at the bottom of the water to the bridge. Based on this information, the captain decides which direction to tow the trawl net. Beneath the deck, the fish processing factory is intensively adjusting its equipment, and rows of pallets have been arranged in place in the warehouse. A team of workers is adjusting the conveyor belt, which is a vital piece of equipment. All the fish catches will be transported via this conveyor belt. Meanwhile, the factory supervisor must ensure that all equipment has been tested and is in working order. They process hundreds of tons of herring here every day. There must be a continuous supply of cold water flowing into the hopper where the herring are temporarily stored to prevent the fish from spoiling. Soon, the trawler reaches the fishing area near the prime meridian. The captain hopes to locate a herring school successfully with the first net cast, so that the task can be completed ahead of schedule and they can return to the port. This stretch of sea is filled with various cruise ships, cargo vessels, and fishing boats. The captain has to be extra cautious to avoid any accidental collisions. At this moment, the fishermen are on the deck, getting the net sounder ready. Another crew member in the wheelhouse is operating the winch to lower the fishing net into the deep sea. One net haul can potentially bring up about 50 tons of herring. This winch is capable of pulling up 60 tons at a time. The operators on the bridge must constantly monitor the situation beneath the deck and maintain close communication with the captain to receive all his instructions. The fishermen need to pay attention to the huge chains, As they often get entangled with the net ropes, they must untangle them. Otherwise, there is a risk that the net may not open smoothly. As the final part of the large net sinks into the water, the next step is to lower the extremely crucial otter boards. At this moment, the operators need to be extremely cautious because hanging overhead are pulleys and steel cables weighing several tons. Any contact with any part of the body could cause injury. These otter boards are made of special steel. They slowly separate the mouth of the net underwater. Subsequently, the ship starts to move forward at a slow pace, towing the fishing net. The engine room beneath the deck looks like a power plant. It houses 3 heavy-duty marine diesel engines. The entire engine room occupies approximately 1/4 of the whole ship and provides a continuous supply of power to the Theodora, the chief engineer. As the only manager on board aside from the captain, makes navigation decisions together with the captain. He is responsible for all the equipment on the fishing boat. There are 2 engines serving as the main propulsion devices, and the 3rd engine serves as a backup. It will only be activated when more power is required in adverse weather conditions or when one of the 2 main engines malfunctions. Each engine can generate 20,000 horsepower, even most of the equipment. Here has a backup device to be used in an emergency in the vast ocean. Checking the oil level is one of the daily tasks in the engine room. Usually, it is measured with a tape measure. Approximately 70 liters of oil must be added every day. Germany's largest deep-sea trawler is about to haul in the first net. The captain has been following the fish shoal on the sonar. When the catch sensor starts beeping, it indicates that the amount of fish underwater has reached the net's capacity. Then the winch is operated to start pulling in the net. It takes about 10 minutes to retrieve the 700-meter-long fishing net. At this time, a large number of seabirds gather, hoping to get a share. Soon, herrings start to appear at the end of the net. The fishermen on the deck begin to prepare a special water pump. They fix the end of the net to the pump head and secure the connection. Next, they put the suction head into the sea. The captain, sitting on the bridge, observes every move on the deck and issues operation instructions at any time. Subsequently, a hose is connected to the side of the suction head. The purpose of this is to pump tons of fish from the net below. Then, the switch of the vacuum pump is turned on, and countless herrings are sucked onto the ship, traveling directly to the hatch on the deck through the pipeline. However, they need to take samples of these herrings. The remaining catch will directly enter the processing plant on the lower deck. As the herrings pass through the chutes on the roller system, they are sorted according to size. Then, they are transported to the processing area via different conveyor belts. The distance between the rollers gradually increases. Smaller fish fall first, and larger ones fall last after that. The herrings briefly stay in a cold water immersion tank and are then sent to the freezer by the conveyor belt. The herrings sampled earlier are dissected to check the amount of roe. Female herrings carry a large quantity of roe, which is the ultimate goal that fishermen strive for. The more roe there is, the higher their income will be. Usually, this kind of roe is sold to the Japanese market, and its price is often several times higher than that of herring meat. The herring meat is typically sold to other populous countries in Asia, or processed into canned herring and other fish products for sale. The caught herrings are conveyed to the freezer. They are placed in neatly arranged rows of iron boxes and then undergo cryogenic freezing at -30 degrees Celsius. 2.5 hours later, these herrings will be frozen solid, as hard as a hammer. Unfortunately, today's catch is disappointing in terms of both the size of the fish and the amount of roe. Continuing to fish in this area would mean wasting time and reducing income. Therefore, the supervisor of the processing plant will inform the captain and offer suggestions. At this point, Captain Gabor must make the final decision whether to move to another location in search of larger and fatter herrings. The store beneath the deck is open once a week. The second mate is in charge of selling cigarettes and other daily necessities there. These duty-free goods are relatively inexpensive. One fisherman said, "There's nothing worse than running out of cigarettes." Cigarettes are an essential item at all times. They give us the motivation to work. Meanwhile, the herrings in the freezer have solidified into chunks. Workers use shovels to separate them into individual pieces and then place them onto the conveyor belt. There are 48 freezers in the entire factory. When everything goes smoothly, the freezing of 90 tons of fish can be completed within 6 hours. Over 300 tons of herrings are processed every day. These frozen fish chunks are carried by the conveyor belt to the packaging machine first. The automatic packaging machine finishes packing them, and then the herrings are transported to the basement warehouse with a temperature of -27 degrees Celsius. 2 workers, dressed in thick cotton, padded clothes, are there to stack the pallets. The work here requires a shift change every 30 minutes because the temperature is simply too low. Since the fish caught in the first net were small and had a low roe content, the captain steered the trawler towards colder waters. Here, there were 5-meter-high waves and biting cold winds. But these couldn't dampen the fishermen's determination to catch fish. They cast the net again and again. There was still a long way to go before reaching the target of 6,000 tons of fish, with each net capable of hauling in 60 tons. It meant they had to make 100 hauls in just 1 month to meet the goal. Deep-sea fishing frequently occurs in adverse weather and on rough seas. These fishermen have to overcome the cold and the waves. However, their earnings are often proportional to their efforts. Typically, each person can earn a monthly salary of around 150,000 euros. If the waves are higher than 5 meters, out of concern for the safety of the deck crew, the captain will order a halt to fishing. At this time, the factory beneath the deck also stops operating. They take this opportunity to clean, maintain, and repair the machinery and equipment. The next day, the weather clears up quickly. Germany's largest deep-sea trawler resumes fishing. By this time, the floating factory at sea has already processed over 150,000 boxes of frozen herring products. Deep-sea fishing is a profession that pushes people to their limits. In the engine room, there is sweltering heat and dirty engine oil. In the fish processing factory, there is a stinking odor and cold seawater. Working on the deck is extremely dangerous, as there is always a risk of being swept overboard by strong winds and huge waves. The workload here is also enormous, with a daily working duration of a full 12 hours. The captain needs to constantly search for areas with more and larger herrings while keeping a close eye on the sea conditions ahead to ensure the safety of all crew members. Everyone has different tasks. On the 17th day at sea, the fishing operations of the Theodora were progressing smoothly. Nearly 4,000 tons of herrings had been caught. However, what happened next worried the captain. Without any warning, the ship's rudder malfunctioned. Technicians were needed to troubleshoot and repair it. The captain reported this situation and recorded these events one by one in the log. Subsequently, he prepared to move eastward at a speed of 3 to 4 knots per hour, then find a safe area away from other fishing boats to drop anchor and wait for the tugboat to arrive. It was estimated that they would return to the port for repair in 12 hours, which meant the fishing operations had come to an end. At this point, the captain gave the order to retrieve the nets. Meanwhile, the factory beneath the deck stopped all operations. The deck crew readied the mooring ropes and made all the necessary preparations for the arrival of the tugboat. Strong winds and huge waves tugged at the anchor chain every 15 minutes, and the crew had to constantly check the state of the anchor. Finally, the tugboat arrived. After over an hour of continuous work, Germany's largest trawler, carrying 4,000 tons of uncompleted fish catches, headed for the port. What followed was the busy unloading work. Well, this is the daily life of German deep-sea fishermen. In the vast expanse of the ocean, a boundless expanse like a huge blue canvas, an extraordinary fleet is cutting through the waves. Each ship is a shining star of human wisdom and the unwavering pursuit of survival. Among them, the trawlers are like the hard-working oxen of the sea, firmly shouldering the arduous task of fishing. However, while bringing abundant fishery resources, they also have a non-negligible impact on the marine ecosystem. Historically, the prototype of trawlers can be traced back hundreds of years. Initially, it was just a simple wooden boat. Fishermen used crude hand-woven nets to try fishing in coastal areas as time went by. With the advancement of navigation technology, trawlers gradually evolved. During the Industrial Revolution in the 19th century, steel began to be used in the manufacture of fishing boats. The sturdiness and endurance of the vessels were significantly improved, enabling trawlers to sail to more distant waters. There is a wide variety of trawlers, and each one is like a meticulously crafted key to unlock specific fishing treasures. The early beam trawlers had a horizontal beam that resembled a strong and sturdy arm, steadily spreading the trawl net wide open. With the development of technology, its operational efficiency has been continuously improved. Nowadays, when it's at work, the fishing boat slowly moves towards the shallow sea area. It's like an experienced miner, carefully approaching the seabed to precisely scrape up those precious benthic organisms. However, this way of operation has, to some extent, damaged the seabed ecological environment. Fragile ecosystems, such as coral reefs and seagrass beds on the seabed, may be damaged by the dragging of the trawl net. Many marine organisms that rely on these ecosystems for survival have lost their habitats. On the other hand, beam trawlers precisely catch specific benthic organisms. If overfishing occurs, it will disrupt the balance of this link in the marine food chain and affect the stability of the entire ecosystem. As for single boat trawlers, they initially relied simply on human effort to open the fishing nets. Now, they use large wing-shaped otter boards that resemble huge wings. As the ship moves steadily forward like an advancing army, the otter boards open the net accordingly. You can often see this type of fishing boat in deep-sea areas. They are like highly trained and efficient hunters, thanks to their unique structure. They can catch various fish species in the complex deep-sea environment. However, due to their wide fishing range and high-intensity fishing, the population of some fish species with high economic value has dropped sharply, and they are at risk of resource depletion. The size differences of trawlers are also quite remarkable. In the early days, small inshore trawlers were like fragile sampans, only a few meters in length, and could only operate in extremely shallow coastal waters. Up to now, small inshore trawlers have grown to 10 to 20 meters in length. They are like agile little birds, nimbly shuttling along the coast. Their hulls are as flexible as dancing fairies. The crew skillfully maneuvers the vessels, sailing freely in shallow bays and estuary areas, adjusting the course and controlling the speed from time to time with excellent teamwork. However, due to the large number of small fishing boats frequently operating in inshore areas, there is also significant pressure on inshore resources such as small fish, shrimps, and crabs. In contrast, large deep-sea trawlers have evolved from small sailing boats that could hardly travel far in the past into the huge ocean giants of today, with lengths exceeding 100 meters. These behemoths are equipped with the most advanced technology. Just like fully armed warriors, in the rough high seas, the crew closely monitors various instruments in the cockpit. Based on the wind, waves, and detection data, they precisely control the ship and head towards the target sea area. The high-intensity fishing of large trawlers not only impacts the target fish populations. Due to their powerful fishing capabilities, a large number of non-target organisms are accidentally caught, which is the so-called bycatch phenomenon. Many juvenile fish and rare species are innocently killed in this process, dealing a severe blow to marine biodiversity. Trawler operations span across the world's oceans, like an enormous spider web covering this blue expanse. In the early days, fishing boats were restricted by technology and could only operate within a very limited area near the shore. Nowadays, inshore trawlers mainly operate in the relatively calm waters close to the coast, within the exclusive economic zones of various countries. Here, they target shrimp, flatfish, and small schooling fish. When the traces of fish schools are detected, the crew springs into action. Some operate the winch to slowly lower the trawl net into the sea, while others closely monitor the movement of the fish school and communicate with the captain and other crew members via walkie-talkies. The ecological environment in inshore areas is relatively fragile. Frequent trawling operations can easily stir up seabed sediments, deteriorate water quality, and affect the living environment of marine organisms. Deep-sea trawlers, on the other hand, are like fearless explorers. From shying away from the deep sea in the past, they now bravely venture into the high seas, sailing thousands of miles away from the coast. In the rich fishing grounds of the North Atlantic, the frigid waters of Antarctica, and the vast Pacific Ocean, they rely on their strong endurance and advanced equipment to move through areas where fish schools are concentrated. The deep-sea ecosystem is complex, fragile, and has poor recovery ability. Large-scale operations of trawlers may have a profound impact on the structure of deep-sea biological communities. Some unique deep-sea species may face the threat of extinction due to habitat destruction and overfishing. The fishing principle of trawlers is both simple and efficient, evolving from the crude fishing methods in the early days. Nowadays, a large net, the trawl net, is towed behind the ship like a loyal follower as the trawler moves forward. The net scoops up everything in its path, including fish, crustaceans, and other marine organisms, much like a greedy vacuum cleaner. When the net is dragged through the sea, you can clearly see the water current carrying fish and shrimp into the net. The mesh size of the net is carefully designed, like an orderly arranged sieve. It can catch specific types of fish while minimizing unnecessary bycatch. However, in actual operations, due to various factors, bycatch is still difficult to completely avoid. Once the net is full, the crew works together to operate the winch and haul the heavy trawl net back onto the trawler, back on the ship. Everyone has a clear division of labor. Some are responsible for sorting the catch, separating different types of fish and other seafood and placing them in categories. Others carry out preliminary processing, such as removing debris and cleaning. Still, others store the processed catch in preparation for the long journey back. The whole process is like a diligent housekeeper tidying up methodically after a big harvest, but during the sorting process, some accidentally caught non-target organisms often die due to injuries or being out of water for too long and cannot be returned to the sea, which further exacerbates the damage to the marine ecosystem. Although trawlers have many negative impacts on the marine ecosystem, from a positive perspective, with the increasing awareness of marine ecological protection, modern trawlers are constantly improving their technologies. For example, more scientific and reasonable fishing gear is being developed. By optimizing the shape and size of the mesh, bycatch can be further reduced. Advanced sonar technology and satellite positioning systems are adopted to accurately locate fish schools, avoiding blind fishing and thus reducing damage to the marine ecosystem. At the same time, various countries have introduced a series of strict fishery management policies. These policies restrict the operation time, area, and fishing intensity of trawlers to achieve the sustainable use of fishery resources. In this way, while meeting human demand for seafood, efforts are being made to protect the balance of the marine ecosystem. Anyway, trawlers play a crucial role in the global fishing industry. With their diverse types, sizes, and operating areas, they're like chameleons that can adapt to all kinds of marine environments. Thanks to their unique fishing principles, they contribute a significant portion to the global seafood supply, making sure that the ocean's gifts can reach our tables. Just like kind messengers bringing presents from the sea. But we've also got to face up to their impact on the marine ecosystem. Through technological innovation and scientific management, we can make trawlers coexist harmoniously with the marine ecosystem and achieve sustainable development.